Okay, so hello everyone. Today we will be solving today's LeetCode POTD, which is check if number is okay. Just a second. Yeah. So the question is check if a number is a sum of powers of three, which is LeetCode number 1780. Okay. So this is our question. Now let's try to solve it. First, first just understand what the problem is all about. Okay. So we are given an integer n, return true if it is possible to represent n as a sum of distinct power of 3. Otherwise, we have to return false. Okay. An integer y is power of 3 if it exists an integer. Okay. So what the question wants to say is that we want to return true if a number can be represented is the power of 3 as a sum of, like, if it's possible to represent n as a sum of distinct powers of 3. Okay, so let's see examples and try to understand the problem. Okay, so here we have n equal to 12. The output is true. Why? Because 12 can be represented as 3 raised to power 1 and 3 raised to power 2. If we add this, which is like 3 raised to power 2, which is 9, okay, which is 9, and 3 raised to power 1, which is 3. So if we sum these two, the answer is 12. Okay, so in that way, it can be represented. Another example is 91. As we can see, 3 raised to power 0 plus 3 raised to power 2 plus 3 raised to power 4, which equals to 91. So the answer is true. In this case, it's false because there are no such powers of 3 which sum up to 21. Okay, so here are the constraints. So now let's see if we can solve it or not. As we can see, I have taken the example where n equal to 91 and we have like 3 raised power 0 is 1. As you can see, I have written the powers. So how can we solve it? Okay. So, as you may be aware of, the concept of pick not pick, which is like used in most problems of DP, or it's also used in recursion also. So it's not specifically DP oriented. But DP is just an optimization technique. Okay. So this problem is of recursion. So how can I say that? Because, like, see what we picked. We picked like this series power 0, 2 and 4. Okay, so we pick this, mm, this, this and this. Okay, so here we are choosing it or not choosing it. Like here we didn't choose it, right? We choose this, we choose this and then this. We haven't choose this one and this one. Okay, so we can identify the pattern. It's pick and not pick. Okay, so one thing which I would like to tell that here is because of this constraint, we can't solve it by storing the values. Like if you store the value and use DP in it, it will give you MLE because the constraint is high. So what we will do, like here I have written for n raised power 12, I have solved it also. We won't store it, we can calculate it dynamically. Okay, so as we increase our recursion tree, expand our recursion tree, we will increase it. Okay, so let me just first do the trial, then we will go into depth. Okay, so I have taken a num which is initially 0, which is like 3 to the power 0 is what? 1, right? So it's there. We have set a limit that the power shouldn't exceed it because then it will exceed the target. Okay, so target if like suppose if you want to find that if 12 is like 12 it can be represented in the powers of 3, we won't be checking for like, we won't be going beyond this or this, I would say. Okay, so we are not going that far. We won't be checking it for 3 raised power 4. Okay, so let me just show you the recursive tree how it's going. Okay, so first we picked it. Okay, 3 3, we subtract it, it's become 11. Now we move further. Here we can see like 9 is greater than 8. 9 is what? Like this 9 is what? It's 3 is power 2. This is our power. Okay, this is our power. Let me just, this is our power. Okay, so 3 is power 2 is 9. We can't subtract it, like it will go negative. So false will be returned. And if we go on the, if we further increase the tree, the 2 will increase, so 3 equal to 3, then also be written false. Okay, similarly here we can see if we didn't pick it. Okay, so if it goes this side, it 11, like what will be 11 minus 9. Okay, so it won't be 0, plus this will increase, it will become 3. 3 equal to 3 we return because like we can't go further. Okay, similarly here we return false. Now suppose if we didn't pick it, what will happen? We come here, this becomes 12, this becomes 3. Like 3 raised power 1 is 3. Okay, so now we start picking it, like picked 12 minus 3 becomes 9, and this also increase. 3 raised power 2 is 9. Okay, so as soon as we do subtract these two, it will become 0, and this will increase, this will. Now before coming to this part, okay, like before coming to this part, we check if our target has become 0. That means yes, so we return true from here, and our answer is written here true, true, and we move out, so our answer will be true. Okay, so in this way we can do it. Okay, so let me just show you the code. The code is very easy one. Let me just show you. Okay, so here is our power, which will increase, which will tell us at what's our limited power. Okay, so let me just, it's telling that if it gets out of bound, we will stop increasing the power. Okay, so as you can see, I've written the same function in the dry run also, like we have 1 0 pn. Okay, so here you can see 1 0, this will be limit, like power limit, and this is our target. Okay, and p. Okay, so here you can see that same thing written. Okay, so as we pass it, is target equal to 0? No, no. Okay, if it will return true, but right now it's not. So if the power is greater than equal to limit, we return false because we haven't found our answer. We are taking this initially as false because we will only move further if this condition is true, to avoid negative elements, or if we want we can also handle it here. Okay, after calling it, but we are handling it before and. Okay, so this will get us answer. We are doing what, like we are multiplying 3 every time to it and increasing the power. That's what it means, right? So at here, if any of them gets the answer true, the true will be returned, true will be returned. Okay, and we will get our answer. If none of them is true, our answer is false. Okay, so I have also tried to optimize it, but it was giving MLE, so I couldn't find a better way than this. Though there are some mathematical solutions, but I don't like them. So, and this is easy to get and more intuitive, I would say. So yeah, this is our solution, and it's running fine, I would say, because runtime is 3 ms. So recursive code 3 ms, it's good, it's not that bad. Okay, as you can see, it's taking less memory. So we are standing some here. If we would have optimized it, like somehow doing the mathematics things, so we would be getting like 0 ms. But yeah, the solution is good. Okay, so yeah, it's an easy solution, I would say. The intuition is also not that hard, it's easy to get. So yeah, this is the solution of this problem. Thank you everyone, have a nice day ahead.